Hey everyone, what is going on? Welcome back to another video here on the channel. In today's video, we're going to be taking a look at comments that you guys have left on this channel and answering them or reacting to them. Now, not always am I able to get to every single comment that has been posted here on the RCexplained channel, as well as the many social media platforms and email. However, if you have a question that you need to get answered for your specific build, leave that on the RCexplained Patreon community. It is a lot easier for me to get to 100% of the questions that are asked on that platform. With that being said, let's jump right into it. I got 6 comments coming your way. Let's start off with the very first one. The first one here reads, "Hey Ryan, no one in the comments asked this, but what is the lifespan of a motor bearing?" The general and most simplistic way to look at this is that there are 3 major factors that contribute to the lifespan of a bearing. You have the dynamic load capacity of a bearing, you have the actual loaded value for your bearing, and you have the RPM that that bearing is going to spin at. The idea behind here is we can't change the actual capacity of the bearing. What is a factor for us is the amount of load that's placed on the bearing as well as the amount of RPM. We know that the amount of lifespan is going to decrease if we are driving that bearing up to a high amount of RPM. However, in general, you should expect hundreds upon hundreds upon hundreds of hours within your radio control vehicle. In fact, I only have one brushless motor where the bearings have actually worn out, and it's only because the bearings are subjected to a completely different environment, which changes everything. I have a few brushless motors where the bearings are over 10 years old and they're still fine to run in that radio control car. Of course, manufacturability and quality defects is definitely going to play a factor and role on bearing life. I hope that gives you an idea as to the bearing life that we should expect with our radio control brushless motors. Let's jump into the second comment here that has been posted. So the second comment reads, "Would I need one for a stock setup?" And this is relative to the video that I did, why I don't use a cat pack in a speed run radio control car. The answer here should really be if a manufacturer has specified all the components without our influence on those components, we should expect that those components have been properly selected and we don't need to add anything in addition to what we have been provided. And for the most part, that is true. However, the only time that we really need to add a capacitor bank to our radio control car setups is when we are seeing ripple voltages that is beyond the 5 to 10% mark. Once we start getting up over 5, it becomes something that we should be monitoring. If we are exceeding 10%, we absolutely need to do something about that. And the answer is to add a capacitor bank. Now, one of the biggest things that I get asked is, how do I know what my ripple voltage is? And the answer to that is, speed controls have the capability for some of them to measure the amount of ripple voltage that we are getting. I use Castle Creations electronic speed controls in many of my builds, and this allows me to get that measurement and know exactly where my ripple voltages are for every single setup. Let's now jump into the third comment on the channel. Third comment that I've selected is, "I fried an ESC by attempting to plug in the battery, but the plug was reversed, and even though it didn't fit, it arced just enough to fry it." This is an interesting one, and of course, if your battery is actually plugged into your ESC in reverse, it absolutely completely can detonate your electronic speed control. What I do find really interesting about this comment is that we typically run 12 cells or lower in most radio controlled vehicle setups. And at this voltage, it's not enough voltage to actually jump a gap. If an electronic speed control has been shorted out by plugging in a battery with reverse polarity, that means the positive actually going to the negative terminal on the speed control, this does suggest that those connectors have actually physically touched and allowed the electrons to pass and move their way into the electronic speed control, ultimately destroying it. Even though a lot of connectors are designed to completely prevent this from happening, it's always a good idea when we're plugging in our vehicle to make sure that we have the correct polarity lined up before we actually physically bring those connectors together. I know in my case that the way I use connectors does not allow me to have this polarity protection, so this is extremely important for all of my radio control vehicles. Let's jump into the next question here. The amp rating is the max current draw at max load, example acceleration. The quicker motor spins, the less it draws. The power you worked out, which is taking amps multiplied by volts is equal to watts, is the power consumption. It has nothing to do with the output of the motor, but more so on how it is built. There's a couple things that we have to dig into for this question. The first thing is that the amp rating is the max current draw at max load. This is correct, and this is how things should be specified on a motor manufacturer's spec sheet. The example that's been given here is to do with acceleration. We have to be very careful when we're specifying this. This implies that the load of this specific motor is actually decreasing. It's the only way that we can get less of a current at a higher RPM. If you take a more general example that's very easy to visualize, a radio-controlled propeller spinning at a specific speed is going to take more torque from the motor to spin that same exact propeller at a higher RPM. And we know that torque and current go hand in hand. So in other words, if we are requiring more torque from our brushless motor, we can absolutely expect a higher amount of current being pulled from that system. If we are accelerating significantly, then yes, we can see that the amount of current under acceleration is going to be higher than the actual current at top speed. Now, looking at the second part of this comment where it states that the power worked out taking amps times volts is equal to watts has nothing to do with the output of the motor. This is definitely not true. It has absolutely everything to do with the actual power output of a brushless motor. When you take the amount of voltage, voltage is related to RPM, and when you take the current, as we mentioned earlier, current is related to the amount of torque output that a brushless motor works in. We know that the formula for the imperial system to calculate the amount of horsepower is equal to the RPM multiplied by the torque in foot-pounds divided by 5252, and that gives us an exact value of horsepower. And the same equivalency is done in the metric system utilizing RPM and torque, and we can get both of those values as explained right from our brushless motor, knowing the amount of voltage and current that we're running it on and using our formulas for kV and kT. Mechanical power done in the imperial system versus the metric system, of course, is equivalent. The only thing that we need to do in both of those systems is multiply by the efficiency of our system to get the actual output that we're looking for. Let's jump into our next question. The next question reads here, that sound was at least 1000 hertz. So how does that correspond? This is a video that we did where we looked at the difference between analog and digital radio controlled servos. Now, when reading this question, I'm not sure exactly what the question actually is, but I'm going to try and do my best to answer it. What I do find interesting is that we're leaving an assumption here saying that something is at least 1000 hertz. It sounds like this is based off of someone's feeling. I don't like working based off of feeling. I like to use data, numbers to figure it out. So let's jump over to the computer. We can use a free program called Audacity, and this is what I use to create all of my audio files. Then what we can do is we can filter out from the video the exact segment that we want to investigate. We can look at what kind of frequencies this is generating. And here in this plot, it is showing that we are generating somewhere just over 800 hertz, and the actual amount is 835 hertz. Now within this video, I do mention that the frequency for digital servos should be well more than 500 hertz. In this case, this is 835, and it's exactly what we would expect. When it comes to the frequency that the servo is utilizing to deliver power to the motor within that servo, higher frequencies generally aren't going to give us any big disadvantage when it comes to performance. If you're worried about power consumption, that is one thing, but if you're worried about performance in terms of the amount of torque and when you get that torque, this is going to be an advantage for you operating on higher frequencies. This is exactly one of the reasons we choose a digital servo over an analog servo. Let's now jump into our sixth and last comment here for the day. This is actually two comments that we're going to cover here in one. So the first comment is dealing with lithium polymer battery packs, and this is another reason why this specific user sticks mostly to budget builds because of false advertising being part of the industry. high price doesn't always mean higher quality. And the second comment here is that the C rating don't matter and are lies. Well, this is actually sometimes quite true, that the C rating really doesn't matter and it's not accurately representing what we have in terms of the battery performance. What we're trying to do here on this channel is break that down, and I have a series that I've started going through radio controlled battery performance, and I have a bunch of batteries that we're going to be testing here over the next several months. Higher prices don't mean that you're going to get better quality. The way that we can get better quality battery packs is to measure their performance and truly understand what they're capable of delivering. That's how we're going to solve this issue. Well guys, I hope you enjoyed the video. As always, like the video if you do. Don't forget to hit that sub button so that I can see you guys in the next video. Thanks a lot for watching. See you in the next one.